All right, so before we get started or back into whatever we were doing, a couple of announcements. First of all, remember you have a test coming up next week, Friday. I did get emails from several of you that are going to Camp CC. I will have worked out by later today. I have a meeting with the rest of the people in the class. What times and where you can take the tests on Thursday before you go, because yeah, we've got that all figured out. So, other thing that applies to everybody, quiz. Our first written pencil paper quiz in here is going to be in lecture on Friday. It'll be the first 15 minutes of class. The quiz won't take you 15 minutes unless you're sitting there confused looking at it. It'll probably, if you know what you're doing, you can do it in 4 or 5 minutes. If you want to take your time, 15 minutes should be plenty of time. It's not a race to finish it sort of quiz. So, in any case, this quiz will cover not everything that we've done so far this semester. The test is going to cover everything that we've done up through the end of this week. But the quiz will cover some of the more recent things we've talked about, like the difference between variables and parameters and constants, and function notation and how to use that, what it means for something to be a function, which we talked about, those sorts of the more recent sorts of things. So there are some other concepts that we've been working on along, and what we started to do at the end of class Monday was kind of reincorporate the idea of this constant rate of change, mixed in with using some function notation to describe the dependent variable values instead of just having to have a number or a formula to calculate. So let's get back to looking at this. We were talking about a sink. We're going to finish up a few questions about this clogged sink. And then we're going to get into, as promised, a GC activity practicing what notation you have to use in order to get it to do what you want graphically speaking. In a few cases, how to do some kind of more complex graphing ideas. And it uses function notation. So, in any case, we talked about this on Monday. We have this sink that's draining at a constant rate of 1.23 centimeters per minute. It starts with some water in it. You can imagine it's a really deep sink, so you don't really care how much time passes. It's going to keep draining for a while. But so suppose we wanted to write two expressions for the variation in the height of the water, the change in the height of the water during the time interval t equals 2 to t equals 6. And we'd been talking about function notation just before this on Monday when we were doing this. So we can write this with and without function notation, and we decided that one way we could do it, the change in the height of the water, just like at the bottom of that race car worksheet that we had, was just to take the two dependent variable value expressions as function notation, w of something. W of t here is the height of the water at time t minutes after pulling the drain plug. Height's measured in centimeters, time's measured in minutes. So we decided that one way we could do this is to write, let's see if this is going to agree with me, w of 6, not quite. Let me get this back to thinner. All right, w of 6 minus w of 2. All right, so w of 6 minus w of 2 does this with function notation. But since there's a constant rate of change, we have another way that we can write this as well. What was the other way that we could express or compute how much the water drops during those 4 minutes, since we know there's a constant rate of decrease? Right, yeah, we've got this rate, 1.23 centimeters per minute, and this is 4 minutes. Because it's a constant rate of change, we don't, for all time as far as we're concerned, time 0 through a while, not infinity, the sink will eventually run out of water, but any 4-minute time period would have the same amount of water drain out, according to what this says, since this is constant rate. That's not true in all situations. Like the race car, not all amounts of time is a race car going to be going the same speed. That doesn't make sense, really. But for small amounts of time, we can assume that. In this case, because we have this constant rate of change, we could also say it's dropping by a rate of 1.23 centimeters per minute times 4 minutes. So either one of those expressions represents the amount, and we could compute this. You could multiply that out, but the negative indicates that height is decreasing. So that's where we were starting from. Either of those two expressions represents the amount of height loss by the water in the sink during that time interval. So if we have this additional piece of information that the height of the water at time 2 is 8 centimeters. So W of 2 equals 8 means the height of the water at time 2 is 8 centimeters. If I want to write a computation for W of 6, instead of talking about how much the water drops during the period, I want to know, well, so what is the new height? We're looking for Y final here. Y initial is 8. The height of the water is 8. And then it drops by a ways to get something at time 6. So without using function notation for how much the water drops, because that would be a little bit confusing, if I wanted to figure out what W of 6 is, this is going to be picking on me today. If I want to know what the height of the water at time 6 is, just like that stuff with Z and the gigabytes of memory and all that at the beginning, if I want to find Y final, I need Y initial plus dy, the change in Y, or initial water height plus, in this case it's a plus a negative, plus that change. So we're starting at 8, and then dropping by 1.23 centimeters per minute for 4 minutes. So what about the second one that popped up accidentally because I clicked the wrong thing? What if the initial height was h instead of 8? Right, just change this 8 to an h. Literally, that's all we need to do. Whatever the height was initially, here's my y initial plus a negative 1.23 times 4, the change in y. So all this is, we've got two sorts of relationships we've got to just put it in a box at the top, so I'm going to use the rest of the space here for other things. But the change in y, when there's a constant rate of change relationship, a change in the dependent variable is a constant multiple of the change in the independent variable. Or in this case, the change in the water height is going to be negative 1.23 times the number of minutes that have gone by. Change in the water height is measured in centimeters. Also, y final is y initial plus dy. If I need to know a particular height at some point in time in the future, as long as I have a starting point, all I have to do is append that amount of change, dy, which I can express, just using y values, or dy, remember, is the same as mdx. So I can even combine these. If you want to think of it like substitution, y final is y initial plus mdx. My starting point plus how much change there is. And I can measure the change either by subtraction, final minus initial. But if I knew the final, I wouldn't need to be calculating the final. Or I can measure that amount of change by doing mdx, where dx is x final minus x initial, the amount of time that's gone by in this area. So what about a different scenario? Instead of time 2 to time 6, what if we look at a different time interval? Time 4 through time 4 plus lowercase m. So some number of minutes. See if you can think about a way to express the variation in height, how much the height of the water changes during the interval, well, this one in particular, once with function notation and once without function notation, kind of like we did in part A. Sometimes you have values, and sometimes you don't have quite enough values, and so we can use notation using functions instead, calling them by name instead of by value. So think about this up here. Again, if you're working on questions and there's too many symbols for you, it's like m minutes, what's m minutes? Go back and make it an easier question for yourself. Think about, well, what would I do if it said 3 minutes? What would I do if it said 17 minutes? If you know what to do if it's a specific normal looking number, then all you have to do is replace that mysterious concept, parameter, where you'd put that regular number to do a computation. So what about for this part B? If I want to express this with function notation, what could I write? Just, yeah. Right, like up above, time 2 to time 6, just like at the bottom of the race car thing, that change between 2 points in time, the change in the dependent variable, when I know what 2 independent variable values I have, I can just plop it in. Now that's not quite a normal number, but same sort of thing. I could write W of final, 4 plus M, the water height at the end of the interval, minus the water height at the beginning of the interval. Now, is this result going to come out positive or negative? The water height at the end of some interval minus the water height at the beginning of some interval. Assuming that 4 through 4 plus m is going forward in time, like 4 is the beginning and 4 plus m is later, meaning m is positive. Yeah, this is going to be something negative because over time, as time goes by, the normal order that it goes forward, the water is supposedly draining out of here. So if I do final height minus initial height, that should come out to be something negative. So what expression without function notation could we use here? Similar to this. Yeah, I've got m dx. Instead of doing dy, y final minus y initial, I can write m dx. The number of minutes that have gone by is dx, which is actually m, so sorry for the confusion, m for minutes as opposed to m for rate of change, but our m is the number of minutes that have gone by, and every minute that's gone by, or every part of a minute that's gone by, for any number of minutes that have elapsed while the water is draining, the change in the height of the water is 1.23 times that in the opposite direction. So in a negative direction, it's decreasing as this time elapsed increases. Not too bad. Same sort of idea, final minus initial, or m dx, rate times the change in the independent variable. Don't let weird letters like that throw you off. If there's suddenly an M that isn't standing for what you like M to stand for, that doesn't mean it's not allowed, or suddenly that M is minutes and isn't rate. You'll see that happen sometimes when your favorite letter is taken by something that's already in the problem. GC included. Sometimes you want to use a specific parameter, and you can't because GC will do the wrong thing if you do that. T in particular causes lots of problems, some other letters as well. All right, so I'm going to clean up all this stuff because otherwise that's going to be right on top of things. All right, so just like the last one, suppose that at time 4, the height of the water is 5.7. Remember, when you read things like that, you can, if you have a story to go along with this, in your head, make sure you're reading what it means, not just, suppose W of 4 is 5.7, not thinking about what that means. So read it meaningfully in your head, and you can make sense of a lot of story problems, the context that's here. So supposing that at 4 minutes gone by, there's 5.7 centimeter deep water in the sink. Let's write an expression for the water's height after the next m minutes have passed. So you see this is talking about the same interval. At time 4, I have some information, and then I want to know what happens by m minutes later. That's that interval 4 through 4 plus m. So if I want to write an expression for the height of the water, that's not a change in the height of the water, that's not a dy, this is a height of the water, a y value, and in fact it's the height of the water at the end of something, so I can think of it as y final. So as long as I have a starting point, y final is my starting point, y initial plus dy, a change, which we just represented a couple of ways, but since it's constant rate of change, it might be easier to think of this just by using, instead of dx, instead of dy as y final minus y initial, dy is this negative 1.23 times the amount of elapsed time. So if we're starting at 5.7 y initial plus m dx plus a change, our starting height plus a change. Well, the change is negative, but the amount of time that's gone by is m minutes. This negative 1.23 m is what we just calculated. if I want to know the new height as opposed to just how much the change is, again, distinguishing between a y value and a dy value, we need to take that y value and append the change. A starting value plus some change, in this case it happens to be a negative amount of change, gives you your final value. So plus a negative, or if you were thinking in advance, you can just write subtract instead of plus a negative. It's okay either way. But y initial plus m dx, starting height of the water, and then minus something, assuming that m is positive. Now, if m were actually negative, that doesn't make any of this incorrect, other than just maybe the picture in your mind about water going down over time. If m was less than 0, that interval would be written kind of in a non-standard notation, but we could still talk about going back in time, and that would make the height of the water larger. That's okay. By doing this generally, we don't exclude any potential values of m. This would work for any values other than 4 through 4 plus m wouldn't look quite normal. We'd have a backwards interval. All right, so let's see. There we go. Let me clear this off. So one last question here, one last situation. Without function notation, how could we express the variation in the height of the water during any reasonably long interval that starts at time t equals 5 and goes to wherever? I don't want it to be to like 1,000,000, because obviously this thing could run out of water before that unless you have an infinitely deep sink, but just some general time t at some point in time in the future after time 5. You think of it that way, it doesn't actually exclude before time 5. But if I want to know what was the variation in the height during an interval like that, how would I express it? If you can think of how I'd write this interval, and this is good. How I'd write this interval, it starts at time 5 and ends at time t, or if you want to say, oh, t final or something like that, that's fine. We don't really need that final there. If it starts at 5 through mystery time t, if I want to express how much the water's height changes during that interval, same as before. Without function notation, we need to have a constant rate of change to know this, or some other formula, but decreases by 1.23 centimeters per minute for each of the, well, how many minutes is that? T minus 5, right. So just like time 2 through 6 was 4 minutes, 6 minus 2 is 4, or 4 through 4 plus m is m minutes, final minus initial. The length of this interval, 5 through t, or the change in the independent variable, generically referred to as dx up there, x final minus x initial, but whatever the symbols are, independent variable final minus initial would be t minus 5. So here's our equivalent of dx up above, final minus initial. So x final minus x initial, only it's not x's. We've got different variable symbols used for our independent variable, but it's the equivalent of up above. And then this is our m. So if I then said, all right, so let's say that the height of the water at time 5 was, and then I give you a number. We could find the height of the water by any general time t in the future, same way as before. So if the height of the, and sorry, this is kind of in the middle of that, I'm going to rewrite it. There we go. Clear that off. Back in here. All right, so we had negative 1.23 times final minus initial, t minus 5. That's our m dx sort of expression for the stuff in green here. If I knew a height at time 5 at the start of the interval, and I want to know the water's height at the end of the interval at mystery time t, same as before, then I could write an expression for the height at the end of the general interval by having that initial, w, plus the change, which happens to be negative change. Y initial plus m dx. So when you have a constant rate of change, not in every situation, but when you have a constant rate of change, You can find a change in the dependent variable by doing that MDX sort of expression, your rate times the amount of independent variable that has elapsed, whatever that domain has elapsed, how much of that you're talking about. And it can even be a kind of general interval like this, 5 through t. If you need to find a new dependent variable value, take an old one and append this change, y initial plus that amount of change. All right, so just make sure you're not getting y values confused with values of dy, or the amount of change. Sometimes they're the same depending on what interval you're talking about, where you started, but most of the time they're very different things, and they always mean different things. All right, so let's talk about graphing then. Let me clear this off. Maybe, nope, sorry. So GC stuff, I know you've talked about some of this in recitation. We talked about maybe a couple tiny bits of GC stuff in here so far, just computation, maybe how to get it to graph. Some details about usage of GC. To be safe, you can always, when you're trying to define a function in there, just avoid using x, y, z, t, n. There's a lot of letters you could just totally avoid. But actually, if you're defining a function, use the special like control 9 or control parentheses or command parentheses to get function definition as opposed to just multiplication parentheses. When you've done that, inside the parentheses, it doesn't really matter what you put in there other than don't use n. N messes things up. T generally messes things up either. But if you put in x, if it's in that function notation definition, it doesn't actually start graphing things for you. If, however, you type x equals and try to put in a value for it, like it's a parameter, it won't let you. If you type x equals 3, it draws a vertical line. And that's all it does. It doesn't assign a value to x for you. It won't assign values to y or z or lots of other letters that are associated with graphing in other coordinate systems. So we've got x and y that we graph with all the time. Z would be a third dimension of that. There's r and theta and phi, which are for polar coordinates and cylindrical coordinates, and t, u, and v are used for parametric equations. There's all these sorts of things. They can cause trouble. If you get a graph when you weren't expecting a graph, go back and change whatever letter you were using in the expression that caused that, and the input sort of letter that you're putting in a formula. Go back and change that to something else, and your problem will likely go away. Like A's and B's are always safe. Just as a note, the n makes that slider feature. Whenever you type n, suddenly stuff pops up. So avoid using n unless you want to use a slider. And then there are 3 constants that are in there. And constant in the normal definition we talked about, it's a value that somebody can look up in a book and everybody knows what it is. E, Euler's constant, pi, ratio between circumference and diameter, and I, the imaginary number, square root of -1. Those are built in. If you type them, GC is assuming that you're using that value. You can't assign I to be something else or E to be something else. You probably would not type pi and hope it to be something else, but just in case, remember that those are going to call up specific numerical values. So just as before we get into our event of the day, take a look at this expression here. This cost of materials in dollars for a certain rectangular box with the base dimensions L feet and W feet is given by this. So something based on the types of materials we're using. It's a weird formula. So it's cost is a function of 2 different input values. We need to know 2 facts about the box before we could compute a cost. So this is called this would be a function of 2 independent variables. So sorry, the part at the bottom, there's not a GC file posted in Blackboard. I forgot to take that line out. But just take a look at this expression here, and I'll put this kind of on the side. If I wanted to compute a cost of a box type 1, I could, box type 1 has length is 8 and width is 4. Or box type 2 has these other numbers. Let's see, let me just open up a blank GC file. There we go. And I'm going to scoot mine down. So it says that this cost is given by this weird computation here. 4LW plus 288 over L plus 96 over W If I wanted to compute the cost of a box type number 1, an 8x4 length and width base box, then I could do this kind of one step at a time. I could say, let's see, well, 4 times L times W would be 4 times 8 times 4 plus 288 over L, which is 8, plus 96 over W, which is 96 over 4, and I can get the cost as $188. And that's kind of an annoying computation to do, especially if I needed to do a lot of this, or if I want to change to box type 2, I need to change this 2.6 and 5.9 in for the 4s and the 8s that I had, or yeah, 8s and 4s that I had previously. So if I want to do more than just one computation or one iteration of find a cost of something, more likely than it'd be more efficient use of my time if I said, oh, well, here's how cost is calculated. Let me make that a function. And I'm going to call it C of L comma W. So you can have like f of x or f of whatever. Let's see. Get a new command line. You can have a single input. You can also have multiple inputs. So I'm going to call my function capital C. And I'm going to use the function parentheses here. And instead of, I'm declaring a function by making up a name, and then I'm going to say what my placeholders for future used independent variable values are going to be. I'm going to use L and W to make it simple for myself. I'm going to use capitals. By the way, capitals and lowercase letters come out differently. You might not have written a whole bunch of functions like this before because they're not things you can graph in 2 dimensions. There's 2 inputs and a 3rd output. So if you're graphing something, it would be in 3 dimensions with this. So not something you do a lot in earlier classes, but I can write a cost function that is just this rule here for LW plus 288 over L plus 96 over W. Oops. Plus 96 over W. And if I were to use lowercase instead of uppercase, suddenly it would not know what I'm talking about. But now that that function is declared, whether it's a function that you're used to using or something like this, if I want to compute a value like I did up above, I don't have to retype the whole formula. All I have to do is refer to what I want done with this formula. So if I wanted to know the cost of a box type 1, that's cost with L is 8 and W is 4. So that's C of 8, 4. And it says 188 right away. Now, I still had to do as much typing, but this time if I wanted to, for instance, compute the cost of a box type 2, 2.6 and 5.9, I don't have to type everything again or like select and copy and paste or delete out all this one number and replace it with another one. I can just say, oh, well, I'm going to use 2.6 for the L and 5.9 for the second. And you can see that the cost is about the same as the cost of box type 1. Or if I wanted to know, well, I've got 10 box 3s and 5 box 1s. What's the cost of that? So let me write that in. If I wanted to find the cost of 10 box type 3 and 2 box type number 1. Oh, well, then I just not, let's see, I want 10 times the cost of, here, cost of a box type 3. So that's C of, and I could even, if I wanted to get fancy about this, I could do something else to have these 10s and 7.25s put in automatically also, but we don't need to get that fancy. So 10 and 7.25. So that's 10 box 3s plus 2 box type 1s, which I'm going to copy and paste because I just did that a second ago. Copy, Control C, Control V for paste. And there we go. So you can save yourself a lot of, if you need to do computations or express computations, whether or not you need the numerical result. Function notation is good for that, but these, if you're doing things repeatedly, You don't need to do it from scratch, write the same plus and minus and multiply and divide and all that over and over and over again. Use function notation to help you out. Save yourself some time so that you can do things like this efficiently. So on that note, and I'm going to delete that. I posted on Monday as a part of what your homework was, the thing that I'm going to pull up right now, which is an example that I would like you to, if you haven't already done so, see if you can do this. And I use t on purpose because sometimes t causes problems, sometimes it doesn't. But if it's in a function definition, it doesn't really cause any problems. If you write it while you're doing something else, it'll think you want to graph something. But let's say that I've got the height of a sunflower modeled by function h of t equals, and then here's this lovely cubic function definition. T is the height, h of t is the height of the flower in centimeters. T days after the seed germinates, so it starts to sprout. The function's valid only up to 10 days after germination, so 0 through 10. So what I'd like you to do is define this function h into GC. You can use x as the placeholder variable while you're doing this. You can use a, you can use any other letter you want, but really if you're defining a function, you can have basically whatever except for n as the placeholder where future values of independent variable are going to go, or where x is going to go when you need to graph this. But you can use x in your definition. But see if you can define that and graph it between 0 and 10, and then get it to show that whole graph as big as you can on your screen. I'm going to put up a version of this in a minute, but see if you can define that function h. Use whatever you want as the placeholder for the independent variable. Pick your favorite letter. You can use x. And then get it to graph just on the domain 0 to 10. And then we're going to do some more things with this. But we need to be nice and big so you can see this. There's single axis zooming features. See if you can make it like this. So somewhere between, like, counting the x-axis by, ones or twos, and the vertical axis by 10s or 20s. If you haven't played around with them, down in the lower left corner, there's these little mountain-looking things. Those are the zoom in and zoom out if you just click on them. If you use certain other keys down on the bottom left of your keyboard, depending on what keyboard you have, the command button or the control button or the option button will make little arrows on one of them, so it'll shrink in only one direction instead of both directions. So this is typically the zoom out, or no, that's zoom in, zoom out. If I hold down one of these buttons, it changes to only left, right. When I push on mine, it's option that makes it just x-axis, in and out. And on mine, it's the command button, only the y-axis, zoom in, zoom out, or zoom out, zoom in, I guess. But see if you can get this to be a relatively big graph across your screen so you can see some details of it, but only 0 to graph only 0 to 10. We'll add some extra things into this. But let me put back up the directions again. There we go. And if you're having trouble using GC, if it's not doing something, raise your hand so we can find you, or ask the person next to you. But yeah, define the function, and then get it to graph between 0 and 10 independent variable values. The independent, like 0 to 10, left to right. Yeah, but independent means, is sometimes referred to as the input variable. graph already, take a look at the next couple of steps. We're going to plot a specific point and draw some line segments. All right. So it's not easy to match one graph exactly to another that you see, but let's see, where is this? Go away. All right, but on this again, if you hit like on Mac, it's Option and let's see, what is it? Option and Command that change these to single axis zoom. So if you hold down that and then click on these, zoom out and zoom in, it only expands or condenses in one direction or in the other. So you can try to make it fit your screen. Another thing you can do if you're lost, you know kind of what values you want to see. It's not perfect, but under this graph, you can set a 2D range and set the minimum maximum. It doesn't actually go exactly to what you say. It makes sure all that's visible, but sometimes it has a lot more space. But under the graph, set 2D range, you can set, this is just the one that's blue right now, that's the minimum X value, maximum X value. To the right, the top and bottom are the maximum Y and minimum Y. No, I'm not going to set those to be 10 and negative 10 because I like the window that I have right now. But in order to get a graph like this, so we can define a function, then have a graph of that function, and use function notation to answer some other questions, I have in here two steps. So one is defining the function, h of x equals, you can use h of a equals. So, and then the next line is just y equals, and then y equals h of x to get it to graph on the x and y axes. Whenever you want to graph something in GC, you need to have an x as the independent variable and y as the dependent variable. So I can define a function using whatever letters I want, but if I want it to graph, I need to have y equals and then that function name with x. So if I went up here and changed this to a's, it wouldn't change anything. If I were to change this to an a, it wouldn't know what to do. It doesn't do what I want it to. So I need this to be an x, and then I've got this graph here. Now, I'm going to slide this down a little. There we go. By the way, all I did is just drag that down using the trackpad to scoot it down a little bit. If you just need a little bit of adjustment, you can slide it around like this. But In any case, to get it to graph only between 0 and 10, just put a comma and then that domain that you want. 0 is less than or equal to x is less than or equal to 10. By the way, if you just use less thans instead of less than or equal to because you can't remember how to get the or equal to, it looks exactly the same, so don't worry about that. But if I want to do some other things, like I said, graph a point, the next one was graph a point on this curve where the independent variable value is exactly, what was it, 4.245. So to graph a point, I know this is something you talked about in recitation. To graph a point, I need a new line, and then that's that control 2 or command 2, depending on your computer version. But you get this like 2x1 matrix. That's how ordered pairs look on here, so that it doesn't do something else. But if I want 4.245 to be the x value, how, using the capabilities of my computer instead of doing scratch work, do I make the y value be exactly the right y value to be on that curve? Yeah. Yeah, use your function notation. And this function's called h on mine. If you called it something other than h, that's okay. Just use your function letter. But for mine, I'm going to have h, capital H, of 4.245. Now, I don't have to do the computation. I'll let the computer do the work. That's fine. And then there's a point. Now, mine's in red because this is set to red. If I want it to be black, I can change this color, remember? But something other than blue is maybe makes it easier to show up. So what we want to do, and we're going to see this a lot, and you've seen this in diagrams. I know for your recitation homework, you did it like you had 2 points and you're drawing kind of a horizontal and vertical line that connect them, like slope style across and up or up and over. What I'm going to do is not that, but just a vertical line between the x-axis and that point. If I want a vertical line, what's an equation of a vertical line look like? X equals something. In this case, if I want it to go to that purple point, where would I, or what would I need for the value in that? X equals what? Yeah, x equals 4.245, the value I just put in there for x. So if I type in x equals 4.245, I get a whole vertical line. Now if I don't want a whole vertical line, if I just want from the x-axis up to that point, how would I restrict this vertically so that I only get a line segment instead of that whole infinitely long line? I need a comma, but I'll put it back so we can see it. Goes from just the axis would be, let's see, is it an x value that I'm restricting by? X between some, yeah, y values. My y values, I only want 0 to where? Yeah, it looks like 20-ish something, but instead of 0 to 20, I'm going to use 0 through, well, I know what exactly that y value is. It's this h of 4.245. So I'm going to append on here my restriction. I want the y values only between 0 and the y value that's on the curve there. So I'm just going to use less than because it's easier. It'll look the same, but I want y between 0 and h of 4.245. I don't have to calculate out what h of 4.245 is. It means that height of the sunflower after 4.245 days. So just kind of highlighting this to point out this. Now, I could do the same with a horizontal segment. If I want a horizontal line, it's a y equals and just a number afterward. Let's say I want a horizontal line segment that goes from the x or from the y-axis out to the same point. What would be the y equals what? What's going to be the number that I use? H of 4.245. Right, we don't need to know that. It looks like it's 20-ish. And by the way, you can click on the curve, say, looks like 20 point, yeah, I got h of 4.245, looks like 20.4375. That might be exact, that might have been truncated or rounded, but that's about what it is. You can click on it and see what it is, but I don't need to know that number and retype it over and over. All I have to do is, the only one number I need to know is this x value that I gave, 4.245, arbitrarily chosen. There's nothing special about it. But if I want that vertical or the horizontal line, y equals the height of the curve when x is 4.245. And that's that whole horizontal line. I only want part of it. If I only want it to go from the y-axis to where the curve is, I'm restricting my x values, just 0 to where? 4.245. Yeah, x values include that 4.245. 0, I'm just going to use simple less thans. I'm just doing it because it looks the same and it saves a little bit of button pushing. But then the only number that I've used is this arbitrarily given 4.245. That was used as the x value. The corresponding y value, height of the sunflower, was h of that, referred to everywhere. I'm going to move this down for just a second. But we have this function, and this 4.245 was given. We don't have to refer to any other numbers. H of 4.245 is a vertical axis number. It's a y value. 4.245 itself is an x number, number of days, horizontal value. So we've done most of the parts of this activity. There's one more part on here that's just kind of vague that says, can you figure out how to use the N slider feature to have be a movable highlighted point and movable line segments instead of just the one that we did? So that would be a yes or no question. Can you figure it out? But if I want to take a look at this, this is all that it took to get all of those parts. If I want this point to be able to move around up and down this curve, instead of being stuck at this one purple position here, 4.245, etc. If I want to be able to use the N slider, which when I type the letter N, I get a slider at the bottom, I can change its values. What do I have to change in this purple point description? I don't want 4.245, I want it to be N, right? Oops. No, not 4n, just n. What would the corresponding y value be for a point whose independent value is n? H of n. So I'm going to change this 4.245 to be an n. Let's see if that worked. Now, there's definitely this slider here. I can slide it back and forth, and I don't know if you can see that. It's kind of small, I know, but I'm sliding this purple point now back and forth. If you can change your n settings. If you click on the letter n, mine's set to go just 0 to 10, so that it won't go off past the end of my curve somewhere and get lost. You can change that by doing that. Now, we changed this from one specific point to a movable point just by changing 4.245 to n in both places, both as the x value and as the independent variable where it's seen in the function notation. So what do you think I need to do to change my vertical line in order to move along? Yeah, change every 4.245 into an n. Now that just changed the height of my line. If I want to change the length of it so that it's not always the same length, which by the way, I can have lines of any length on here. It doesn't really matter where they are. But if I want it to go all the way to that point, I don't want it to go to h of 4.245 unless I want it to be the height of this spot right there. I want it to go to h of n, right? So if I just change every instance of 4.245, that one specific value, into an n, then I get a moving point. This is the same concept I was talking about earlier. If you're trying to do a problem, there's too many symbols and you're like, I don't know what w of t is and w of t plus 5. What if it was w of 7 and w of 7 plus 5? What would you do? Think about it with more numbers involved, and then see if you can say, well, it wasn't a 7, it was an n. Take the 7 out and put it in n. Then you've got what you want. Same with this y, the horizontal line. If I want it to be movable as well, I'm just going to change those 4.245s into n's. And then we've got a magic drawing. It goes like this. So Those sliders are pretty useful for pointing things out, but just in working through how to write those expressions, you can see you can use function notation in a lot of ways, both to express x and y values, also to express domains and ranges, or just the limits of a variable, what section you're interested in for line segments. All right, so again, Friday, there'll be a quiz covering function notation. Got some more practice at that today. Function notation, variables, parameters, constants, meaning of a function. Next week's a test. I'll post your homework and a video shortly after class. All right. Oh, by the way, my office hours are canceled today because I have to go to a meeting, so I'm not going back to my office right now. I apologize.
So, just for you, right? Everyone else is
Wait, I'm sorry. What?